I think I'll kick off now. Thank you everyone for joining this EARPA Projects Unveil webinar. I'm the communications officer for EARPA, and I'll be kind of leading just the moderation part of it. In today's webinar, we're looking at three different automotive research projects. One is the Le Mesurier project, where Simon Edwards will speak about it. The next is the Magellan project, where Wissam Deep will speak about it. And finally, the FlexCross project, where Sergi Parada will speak. Just to let everyone know that the webinar will be recorded and slides will be shared afterwards. After the three speeches, there'll be a small Q&A session happening at the end also. So if you have any questions throughout the webinar, just put them in the chat and we'll get back to them at the end of the session. So with that said, I'll kick off the session. So for those who might not be so familiar with EARPA, is the European Automotive Research Partners Association, which brings together the most prominent independent R&D providers in the automotive sector. And we're based in Brussels, and we're a network of European automotive researchers, and our members collaborate and work on road mobility projects. And in addition, EARPA helps shape and influences the European research agenda. EARPA has around 60 members from across Europe, and it varies from large and small commercial organizations to national institutes and universities. EARPA is widely active through different programs from AirTrack, CCAM, 2.0, Bat4EU, and CHIPS-JU partnership. And our members are involved in many European projects. And from 2021 to 2024, our members undertook around 40 projects within Horizon Europe. And we have a success rate of around 42% within cluster 4 and 5 of projects being granted successfully. So it's quite a successful network of organizations within EARPA, and we're always looking for more to grow. One final point is that EARPA has their big event happening this month from the 30th of September to the 1st of October, the Forum. And it's a 2-day event where the first day is a networking reception. And the second day is a conference session where there's plenary discussions, keynote speeches, an exhibition. And yeah, it's a great place to be. And it's in Brussels also. And if you're keen to attend, it's a free event. So just scan the QR code in front of you now if you're interested. I'll also send you the link afterwards. So now moving on to our speakers. Our first speaker is Simon Edwards, who's the Innovation Director for Ricardo. And he'll be speaking about Le Mesurier. He is based in Germany and has over 40 years experience in the automotive sector. And Simon has been involved leading the coordination of Mesurier project supporting 2.0. So Simon, you can share your screen now to show your slides.
I hope you can hear me now, David.
Yep.
And I'm trusting you can see the slides for a moment as well.
All good.
Good. Thank you. Well, thank you, David, for the opportunity and invitation to present, and congratulations to EARPA for organising this event. And naturally then, good afternoon, ladies and gentlemen. For the next 15 minutes or so, I'll make what feels like a very brief presentation on the Le Mesurier project. So I will go through slides very quickly, but as David has mentioned, those slides will be available for you. So please take a look at them in your leisure after the event as well, because there are a lot of slides and quite a lot of information here coming up. For those of you who have even less time than I do to make the presentation, here are the headlines of the presentation. This is the one slide if you can't wait. So Le Mesurier is a 2.0 CSA, Coordination and Support Action, and 2.0, the public-private partnership for the automotive sector in relation to, let's say, clean vehicle technologies. This has a range of objectives, measures of success, key performance indicators that we all, but especially the project proposers and coordinators, should be aware of. And so hopefully this presentation will be of some use to you, since Le Mesuré provides the method to measure those KPIs. And when we've been doing that, the indication so far is that 2.0 is making good progress. As I've said, this will be a very brief presentation, but please have a look at the slides and attend the future webinars as well, which I'll give you more information about right at the end of this presentation. The structure of the presentation is shown here. Very simple, very straightforward, so I hope that's all okay for everybody. And therefore, by way of introduction, just in the first place, this is a little bit of information about the project from Cordis. The project started in January last year. It will be completed in December this year. You can see the rest of the details there, but it's a group of 13 partners working together, but more importantly, it's 18 EARPA members that you can see here. So quite clearly, this can be classified as an EARPA proposal, an EARPA project, given our usual guidelines. So we're well represented, also, of course, in the presentations for later on today as well. But we need to look at the 2.0 partnership in a little bit of detail to understand what Le Mesuré is about. But in the first instance, we can take a step back and look at the European Green Vehicles Association. That was the predecessor to 2.0. It was a success. Please have a look at the impact assessment for EGVIA, the report and all the presentation as is shown on the left-hand slide there, because it was found that EGVIA had a positive impact on decarbonisation, economic growth and competitiveness. So going into Le Mesuré, the question was, well, what is 2.0 likely to achieve? And 2.0 was set up on the back of EGVIA's success. It has a somewhat similar scope, extending through the 4 pillars that you can see here. But I know that EARPA knows those 4 pillars well, because there are many EARPA members who have been contributing to the definition of what 2.0 wants to achieve and what those 4 pillars are and what they contain. But whilst the pillars are good at judging whether an impact is being made, it is difficult. So it's quite difficult to go from the beginning of the projects right through to understand what the impact of the technology that is being developed. Hence, the Le Mesuré project was called for to help us set up a project, set up a process to make that judgment, to understand how we can do it. And it's made even more difficult because the direct influence of 2.0 reduces over time, as this diagram here shows. This diagram is from the Strategic Research and Innovation Agenda of 2.0. The actual projects recede into the past on the left-hand side as we move towards the right-hand side of this diagram, and the technologies, the components and the vehicles reach the market. So the actual measurable impact of the 2.0 activities, the R&I, only increases at the end of that time period. And whilst we can say that coincidence is not causality, we know that the rate of scale up by the suppliers, the manufacturers and the rest of the sector's transition, if you like, is 1/3 roughly dependent upon the technology, 1/3 on the standardization and 1/3 dependent upon the ramp up of the production, increasing the economies of scale, if you like. So it's important that we understand this whole process and that we can represent it so that we can estimate the impact of the activities of 2.0. And the situation is made more complex because of the extent of the 2.0 objectives. There are 3 tiers of general, specific and operational objectives with over 20 objectives in total. But it's made more complicated even because those objectives are being measured by over 40 KPIs or 40 measures of success. And it's those measures of success that Le Mesuré has been looking at. The KPIs are clearly listed in the 2.0 SRIA, so please have a look at that document if you're working inside of EARPA if you don't know it already. But it's more complex again, because whilst some of the KPIs that you see there are fairly straightforward to measure, some of them are more complicated with multiple sources, advisory footnotes, and so on. So we had to, inside of Le Mesuré, differentiate between those more straightforward KPIs, which we've called direct KPIs, and those more complex KPIs, which we've called compound KPIs. The direct KPIs are many in number, the majority of those 40 that I've mentioned, but they're relatively straightforward to measure. Whilst the compound KPIs are few in number, but require much more analysis to quantify. So let's talk a little bit now then about the Le Mesuré project and the results so far. So the process of Le Mesuré, the project flow, is represented here from left to right, if you like. We're looking at 2.0, the 2.0 portfolio of projects and their results and other sources. And then we're trying to look at that data in terms of either the direct KPIs or the compound KPIs as shown here, and doing some accounting of those values and disseminating that. And that's what we're doing a little bit today. But we're also looking at assessing the interactions of the impacts of the various activities of 2.0 and coming up with a set of recommendations as well. So we'll hear a little bit about that today and more about that in coming meetings, etc. The Le Mesuré project has 4 objectives. They're shown here. Clearly, we've just about completed objective number 1, the accounting of the activities of 2.0, and we're going through objectives number 2 and 3, and what you're seeing here is part of the achievement of objective number 4. But what have we found out so far? So I'd like to give just a few minutes then in relation to what we've found out in each of the work packages. So the team have worked very hard to define and practice a process that leads to the quantification of the majority of the KPIs based upon the 2.0 portfolio of project results so far. So we've got those many steps, as you can see here, and many of you who are project coordinators will know that you've helped us, you've helped Le Mesuré by answering a questionnaire, maybe being asked for interview in relation to some of the measurement processes. Really, thank you for your responses. That's made Le Mesuré possible. And we've looked at about 30 projects overall. This is a bit too small to read, but you get the idea here. 30 projects on the left-hand side relating to their different timing. Clearly, for many of the projects, it's relatively early in their duration, but you're supported nonetheless, thanks. And as the process goes on to continue, then there'll be many more projects coming up, projects that can be evaluated using the same sort of process. If we look at the results of the analysis so far, we found out that most of the direct KPIs are being addressed by almost all of the projects, and the projects are addressing usually more than one of the KPIs at any one time. So that we know it's progressing, but we also know it takes time to go through this process, and perhaps the timing of the Le Mesuré project was a bit too early for many projects, but we're recording this learning for Lucy and the team at 2.0, and they're leading to recommendations and future assessments for future partnerships as well. But overall, the indications are so far, as shown in this table here, where we've got the KPIs down the left-hand side and then the achievement scale on the right-hand side here, that we've seen accomplishment of some of the KPIs already, despite only being halfway through Le Mesuré. We've seen good progress in many of the other KPIs, for example, in relation to the outcomes of cost reduction and so on. And there are only 1 or 2 KPIs, as we've seen here, where it's been a little bit difficult to measure, or perhaps the KPI itself is unachievable. So overall, good news for the majority of the direct KPIs. So that's the majority of the KPIs overall, but we've got to think about the compound KPIs as well. And the process for measuring those is more complicated given the complex nature of those KPIs, involving vehicle park modeling to come up with the numbers at the end of the day. The process is shown here overall. Remember that we're just talking about a few compound KPIs, looking primarily at the engine and emissions of the road transport park in Europe. And to analyze these effects, we used 3 different models for good reason, as noted here. And those models themselves are listed on this slide here. They're known to the majority of us. The first 2, that's either Copert and Sybil and Primus tree move, they're already in common use by the European Commission, by the JRC. So we add an extra model to that, but the processes weren't well known. And we collected the current and relevant data to generate a set of baseline values for these 2.0 compound KPIs, but we also collected the pre-2.0 projections of the values of those KPIs, and we called those intermediate values before the measurement actually got underway. And then we followed what was we found it was mostly too early for the projects themselves to generate values for the compound KPIs. So we moved to a backup plan in which we developed our own Le Mesuré digital twins and used these digital twins to project the future KPI values. These models, you will hear about more from Amicia during the EARPA Forum in a few weeks, so I'll not say very much about them now. But it's important to know that we have a means through Le Mesuré to measure the energetic and emissions impacts across all vehicle types in the European vehicle park. Here I show a couple of example results relating to the energy consumption against vehicle speed for a future heavy-duty vehicle as is being developed in 1 or 2 of the projects under various conditions, for example. And it was rewarding to note that when we did our digital twins, for example, here from the type of L category vehicles being developed in the Giants project, and then they did the same type analysis for their own demonstrator vehicles, we got very good correlation between the results from the Le Mesuré digital twin and the results from the project digital twins themselves. So that was rewarding for the project. Here is an example now. We've got a recognized means to account for the findings of the 2.0 project portfolio and estimate the compound KPIs. Clearly, if we look on the left-hand side, projecting the European road transport CO2, its change in millions of tons of CO2 over the years, the results seem very familiar. It looks like we're on the path that we have been planning for a long time. But when we looked in more detail, and again, you can see here on the left-hand side something about the energy consumption projections in the European vehicle park over the next few years, we found that the actual running 2.0 projects are suggesting that the initial projections can be improved and be more positive than the intermediate scenarios suggested. So saving many more tons of oil equivalent energy than what we were originally projecting. And the use of those 3 different vehicle park models has allowed to look at those variations over time, the possible impacts from different perspectives. For example, over a life cycle, as is looked at in MOVE-ID, compared to either a tank-to-wheel or a well-to-wheel analysis, as is done in the 2 previous models that I mentioned. So that's what we've been doing in terms of accounting for the different KPIs, but I just want to say a little bit more about what's to come. I've got a couple of minutes left. I hope to be able to do that. We're looking also at the bigger picture. So clearly, if you look at the 2.0 partnership inside this green box here, we've got the general, the specific and the operational objectives. And along the bottom here, we've got a range of different projects that we're trying to do the accounting for inside of the Le Mesuré project. But we're also looking, let's say, above the 2.0 partnership at its generic objectives, which are also 6 in number. So there are even more objectives that we're trying to look at as well. It doesn't stop just with the KPIs. But as projects, you've been contributing and looking at that, and you clearly think that you're contributing to those generic objectives as well. You can see some of the number of projects that we've found are contributing to those objectives here. And we're also doing a much more detailed analysis of the complex relationships, the interactions between the different objectives and the multiple KPIs. But my time's running out, so more on that next time we get to talk. And there will be a next time because there's a lot more information available online for the Measure A. You can see some examples of that here, and you'll see a bit more at the forum. Only today, there is a We Drive to Zero interview reported about the Le Mesuré project. And as we go forward, there will be several other conference presentations in relation to Le Mesuré as well. Towards the end of the project, we'll have some one-pagers for each of the KPIs as well to show you in detail what we've found. But right now, it remains for me to suggest, please keep dialing in. We've got 2 webinars coming up, one in October and one in November, giving much more detail and time to show you the actual results from 2.0. And then there'll be a final General Assembly and meeting, which will be open and available to many of you. So thank you very much for your attention. I realize it's been a whistle-stop tour. Sorry about that, but I hope I've kept to time, given the other presenters a chance. Thank you very much.
Thanks very much, Simon. I'll take back the screen, and
please do so.
Lovely presentation as well.
Thank you.
So I believe you can see my screen again. Wissam Deep is our next presenter, and Wissam is the Business and Partnership Development Manager at IFPEN. He's also an EARPA Executive Board member, and he is leading the development of European funded collaboration projects in sustainability, and he'll be on sustainable mobility. He will speak about the Magellan project. And Wissam, the floor is yours.
Thank you, David. So hello, everyone, and thank you, David, again for the introduction, and for EARPA also for this opportunity. So in the next coming 15 minutes, I will share with you the challenges, the objectives, and the initial result after 18 months of work of the Magellan project, which is a magnet and resilient supply chain, and in which IFPEN is a member of the consortium. So first of all, let me share with you a few data about the project. So as I said, Magellan is a Horizon Europe project coming from Cluster 4 call. It's an innovation action. There is 14 partners inside the consortium, and the consortium coming from 8 different EU countries with 7.5 million of funding. And it's a 3 years project starting since the beginning of 2024. By the end of the project, we are heading we are expecting to have a TRL 7, so a prototype demonstration in an operational environment. Maybe you can go to the next slide. Yes, so just a brief introduction of the different members of the consortium. So it's as I said, we are 14 partners with Orano as a coordinator from France, covering the whole value chain of the magnet, from the recycling, you will see later on, from the recovery of the magnet until the production to the use at the end of the magnet with CRF, for example. So there is a magnetic CRF from Italy, a battery life cycle company, Comet from Belgium, CEA and IFPEN from France, Université de Liège, Tecnalia from Spain, TUD, GTK, Lomartov, RTD, and DIT Raw Materials. So the challenge that we are facing, you can go to the next slide, please, David. Yeah, so mainly permanent magnets contain rare earth elements, as you know, and particularly neodymium, and these permanent magnets play a key role in the green transition. Actually, today, these permanent magnets, as well as the rare earth elements, metal, are mainly produced outside Europe. That's why we need, in order to strengthen the European sovereignty and the Europe's sovereignty and reduce dependency from other outside country, a European PM permanent magnet supply chain is needed to support first the growth of the EV market and also to accelerate the energy transition. So as a part of this strategy, it's necessary to implement a permanent magnet recycling on a large scale. And if we just check few numbers about the potential of recycled magnets today, in 2020, less than 1% of all magnets produced were recycled. which is estimate around, as a first estimation, we have around 200 tons of neodymium could be recovered only in the EU country. And this is could be doubled, this number could be doubled by 2030. So 400 tons of neodymium, which is essential, which is really a key component, a key element in the permanent magnet, can be recovered only in the EU countries. And this is equivalent to approximately 1,200 tons of new permanent magnet. And if we, by approximation, if we suppose that we have an average 1.5 kilogram of permanent magnet in electric motor used for traction, so we can produce 800,000 electric traction motors only by using neodymium, recycled neodymium. So if you go to, so the idea of the project, the project proposes a solution based on the three pillars of the circular economy business model, the make, recover, and use. So if we first focus on the make, the idea is to better use of the rare earth element in the production of the magnet. For example, increase the sourcing of recycled heavy rare earth element like dysprosium or terbium in a short loop recycling process. Second, enhance the use of secondary rare earth element in a new high performance magnet and meeting directly the traction motor requirement. And finally, try to substitute neodymium. As I said, neodymium is geopolitically sensitive and expensive, so try to substitute this in the composition of the new magnets, the neodymium, by less critical, let me say, rare earth element like cerium or lanthanum. This is on the make side. If we go to the use, we will try to better use. Go again, please, David, to the previous slide. No problem. So we will also try to better use the permanent magnet inside the electric motor. So we will first facilitate the magnet recovery and minimize material losses during reprocessing. Try also to avoid irreversible gluing when we fix the permanent magnet inside the rotor of the electric motor. And finally, which is also very important, try to improve the performance of the electric motor with a reduced quantity of permanent magnet. So we will reduce the permanent magnet mass per kilowatt. And finally, if we go to the recover side, and this is also a challenge for the project, we will try to better recover the magnet by upscaling the magnet to alloy roots and employ functional recycling to avoid downcycling. So all these solution, we try to make some objective behind that. If you go to the next slide, please, David. So as you can see, the objective covered the whole cycle. So from the recovery, increase the recovery of the rare earth element by working on the magnet to alloy route until the near net, developing the near net shaped magnet, which means that we will manufacture the magnet directly in their final usable geometry to minimize waste and machining. And then we will also work directly on the design of the magnet shape, which correspond to an optimized and perform well high performance electric motor until the demonstration. As I said, the project is a TRL7 by the end. We need to reach TRL7 by the end of the project. So we will demonstrate also the solution demonstrate the different process, validate the different process. And very important point, we need also to demonstrate the sustainability and the business benefit of the Magellan solution that we are proposing. So we need also from the economical point of view, try to also validate that the solution is viable economically. Next slide. So all these objectives, we try to, in order to better track in a better way the project progress. These objectives are declined in different KPI, as you can say, from the recovery until the demonstration. I will not go into details into the details of the KPI, but you have them all here. Maybe one important KPI, for example, in the near net shaped magnet, as I said, we will try to substitute the neodymium by cerium, so achieve a 40% substitution. This is a very challenging challenging, let me say, KPI. On the other hand, also, for example, we will try with a better use of the production side, so with a PIM process, powder injection molding process, try to decrease also the waste during the loss during the production. And on the motor side, we will also try to optimize the flux or the lamination, let me say, or the performance of the electric motor in order to use less permanent magnet. So on the next slide, I would like just to briefly also share with you that, as I said, Magellan will cover the whole value chain from the sourcing until the dismantling. So you have the sourcing of the different permanent magnets, and then we will try to sort these magnets, go to the production of the new magnet with recycled element until the design of the electric motor using recycled magnet, manufacturing also of the magnet, but also of the electric motor, the assembly, the validation, and then at the end of the validation also we will again disassemble the motor and get again the magnets and the loop, close the loop. So we have a very complementary, there is a good complementary between the different partners of the project, from academia, research, and industry. And in parallel to all these steps, we are running also life cycle analysis to be sure that to quantify the CO2 footprints of the different solution, and especially to compare with the reference what is done today on the recycling of the magnets. And as I said, also we need to show the viability of the solution. So a business plan and exploitation strategy also is running in parallel of all these different steps. Can you go please to next slide? So after 18 months of the project, as I said, the project is 3 years. So we are more or less on the half of the project. We already, from the user side, we already define the application. So as you see, we are looking for very advanced electric motor that in the vehicle, the Maserati vehicle. We are talking about a really very advanced electric motor with a lot of magnets inside, 450 Newton meter to 275 kilowatt at peak power. So the idea really to take very advanced electric motor and to show by the end of the project that even with recycled magnet we can also get again the same performance. So from the left side we can talk about the recovery of the magnet. So 40 kilogram of permanent magnet from motors and e-scooters and e-bikes were already extracted by the partner. We are working also on the extraction on end-of-life battery electric vehicle and hybrid also electric vehicle rotors. Characterization and the decision protocol to characterize and sort the PM is already also has been already also initiated. And then if we go to the right side, we can see we can talk about the production of the magnet. So CEA and Orano have successfully validated a reference alloy composition of the magnet on an existing pilot line, which is today in CEA. A first batch of powder injection molding magnet were also produced. For now, we are just validating the process. So this first batch was produced with fresh material, not recycled one. As I said, also that we will work to we'll try to substitute neodymium, which is very critical for the magnet, but also geopolitically very sensitive by less sensitive, let me say, heavy rare earth material like cerium. So a first POC stage has been done by TUD, and the good news also that Orano pilot line equipment has been received, and we in the coming months it will be I mean we will start by the exploitation of this new pilot line. Finally, two more points. So CRF and IFPEN. CRF has provided 3 reference motors that will be characterized and tested at IFPEN, and IFPEN is working on a digital twin platform that will be used also beside the characterization of the reference motor. It will be used also to design the new electric motor adapted, where the shape of the motor or the rotor will be adapted also for non-prismatic magnet with a recycled element. If you go please to the next line. Yeah, so finally, I would like also to share one important point that has been achieved by Magellan project on the lobbying, let me say, part. Yeah, so we have done, there is a first study done that show also that the both secondary and primary sources and the volume available are economically challenging, and we need really irregularity support on this stage. So a key message has been given to the EU policymaker. If you really need to unlock the circular economy potential of permanent magnet, this should start by with a better waste and stream visibility and traceability. We really need to know where we can find these magnets and the quantity that we can find, and also the quality of the magnets that we are looking for. So it's important to say that Magellan also, beside the technical part, we are also working a lot with 8 other EU projects on lobbying and discussing also with the European Commission. Yeah, so the next slide, and I will finish with this one. Yeah, so as I said, the expected result for Magellan will be mainly divided by, there will be the technology part, so we will demonstrate the technical and economical viability of the recycled permanent magnet, especially they will meet the EV market and the traction motors. And then on the other side, also on the environmental side, we will show that by using recycled magnet, we will reduce, this will contribute to reduce the emission used for the production and manufacturing process, and especially we will avoid a primary mining extraction of millions of tons of ore needed today for light rare earth elements. On the recycling side, as I said, one of the challenge of the project is to try to increase the reuse of rare earth element content in the magnets, achieving a 50% increase in yield. And we are also looking for the price, the cost of the recycled magnet, which is also critical to be able to sell at the end these magnets. So yes, the final message that I would like to share, that Magellan project is looking to pave the way for a 2,000 tons per year of magnets supply chain, which could be represent 10% of what we are looking for in 2040 for the EV market. And that's all for me. I think if you go for the next slide, yes, so you have the impact, but I think I already take 16 minutes. So yeah, sorry for being too late.
Worries. So, thanks very much, Wissam.
Thanks a lot for all the partners and for helping me also getting all these interesting slides. And if you have any question, please don't hesitate. Thank you.
Thanks very much, Wissam. So finally, we have Sergi Parada, and he is a researcher at Eurocat, and his work focuses on mechanical behavior and fatigue of materials, with a particular interest in additive manufacturing. Sergi, I leave it to you.
Perfect. Thank you, David, for the nice introduction, and also EARPA for the opportunity to present our project here. So I would like just to start with this first slide, just talking a little bit about the funding of this project. So it's in the frame of this call about the testing safe and lightweight vehicles. So here you can see a little bit the characteristics of the project. So we're talking of a project of about 4 years with 4 million euros, 11 partners, and also 6 countries. We'll see in the next slide that, yeah, next slide, please, David, thank you. So here we have these 5 different branches, I would say. So we have these research centers. So the project is coordinated by EURECAT, and also we have this Fraunhofer and Virtual Vehicle, just working on the developing the new materials and the new solutions to be applied to the vehicles. Then we have universities, Lul University and Krems University. Different industries that at the end are the ones important for this kind of project, right? In order to transfer all the knowledge to the reality, I would say, or to the final component. And we have this GMAT, Gestam, Aerobase, and also IDRIA. In fact, IDRIA just joined very recently to the project in a open call, and yeah, will help us just to produce some components that we'll see later on. Also, we have Industrial Research Center that belongs to Stellantis, so this is CRF. And finally, the standardization body, UNE, in order to just to help us to develop new standards and see how we can just once again transfer all the knowledge that we're developing to the industry, and how the industry can benefit also from this new development. So in the next slide, we can see a little bit the ambition of this project. That I think that the image is quite illustrative. So what we are talking about is to reduce the weight of the vehicle. That is, it sounds quite easy sometimes, or quite straightforward. But here also what we want to do is, of course, reduce this weight, but maintain at least the same safety of the vehicle, or improve the safety performance of the vehicle, so by reducing the injuries and fatalities due to the different crashes, right? So we want to reduce the weight of the vehicle, so by removing material, let's say, while maintaining the safety of our vehicles. So if you want to know more about this project, you can just see here this video. We will not watch the video now, but well, you can just access to this link that you can see here below, or afterwards you will have the slides, and you can just simply just watch the video, and you will have an overview of the project. And we'll see how we are just working in this project. So basically, we're started with this motivation and requirements, right? So it's clear that when we want to develop a new structure for a vehicle, we need to include a lot of stuff, right? So we need to include all these different legal requirements, but also the Theresian, well, all the points that you can see over here. And also we are just adding this key points that you can see in the right hand side. So basically, that we want to use full aluminum in order to reduce the weight of the vehicle. We want also a full crash validation of our solution, and of course we have this interaction with other funded projects in order to have a really good result in our system. And in this case, as you can see in the graph, or in the picture of the vehicle in the left-hand side, you can see that we are just, in this case, focusing on the frontal part. This is mainly because the 70% of the crashes nowadays are frontal crashes. So this is why we are just focusing on this frontal crash. So if we go to the next slide, you can see over here that, well, when we start designing these components, we need to consider a lot of points. So it's probably all of you know about air and cab safety, so we are using this as a reference. And in this case, we are using the setup that you can see below. So just this barrier with a defined weight, speed, and an overlap. And also we are using another model, the model of the vehicle. That is, this model is proposed by Gestam, and it's a battery electric vehicle. And we're just crashing one against the other, and we're trying to understand what's happening during this crisis scenario. So we want to know which is the dash panel intrusion. This is a good indicator about the crash performance of our structure. Also, we need to accomplish with central deceleration, so we cannot just simply put a wall there and just have a super huge deceleration, that this will have an influence to the passenger of our vehicle. So we need to understand these kinematics and the chronology in order to program, let's say, these decelerations of our structure. So by knowing or by considering all of these different aspects, if we go to the next slide, we can see the strategy that we are following. So basically here we are using this GLab reference model, the one proposed by Hestam, and we are just introducing here an HPDC aluminum part. That this part was developed in a previous European project, this Salema project. In that case, the idea was to demonstrate that we can use a high amount of recycled aluminum to produce an HPDC part. And then we are just modifying this frontal part of the vehicle in order to include all the different aluminum components that you can see in the right-hand side. So basically the HPDC parts, the extruded profiles, and all the different components that are surrounding this frontal part. So by considering this this frontal part, if we go to the next one, please. Here you can see that basically we have, as mentioned, this HPDC and the extruded profiles, the 6063 extruded profiles with a T5, and we are including, or we are working in this optimization phase where we are just, of course, considering all the different loads that are required for this component. Then we are also including and developing new testing processes. So basically based on fracture toughness. And since we know that from previous projects that this is a really good indicator for a crash performance of metallic materials. And since we are just addressing some structural components, we are also developing new rapid fatigue tests in order to assess the fatigue performance of these components. And this way we can see the performance of the full components. Then we are just using a lot of simulation in order to develop and optimize this Salema component. You can see in the lower part, in the right-hand side, this in blue, these components that the Salema component where we just put some holes. This is just to trigger the folding behavior of the component that where we are while we are working in developing this geometry in order to have a better performance. And then here we have the AVFF and topological optimization. We will see this later on. And finally, we'll just include all of this knowledge in a full-scale vehicle, and we will see by using the simulation how we can validate or homologate the performance of these new structures. So if we jump to the next slide, we can see the AVFFs. That basically here, this is a new concept that we've developed, is adding a valid fraction of features, that the main idea is to produce or to have some reinforcement in these extrude profiles that we saw in the previous slides. So basically we're using the LMD technology, so the laser melting deposition technology, where we are using some aluminum powder and we are just melting this powder and we are depositing these reinforcements on top of our tube. So you can see here in the right-hand side that we can just print different geometries, these kind of fish bones or the honeycomb structures. And the main idea is that by simply using this strategy or this reinforcement, we can reduce the weight of these components while we are maintaining the same energy absorption set. So that at the end is what we want in our project, right? So we try to use thinner materials or less material, but also maintain the same performance of our component. So in the next one, we can see the some trials that we carried out. As you can imagine, it's not that easy. So here we just tested different powers and different setups in order to have the best AVFF geometry, the best performance. And also in the next one, please, here we produced our own powder. So here you can see that this powder was produced by ERICAT and then was sent to Fraunhofer, that they were just printing the reinforcement. In this case, at ERICAT, we produced this aluminum alloy with added zirconium in order to have a better performance of these reinforcements, and that will be just introduced or deposited on the surface of these extruded profiles. So in the next slide, here just to mention that, of course, it's clear that the event cap defines some situation, right, some scenarios, but what happens when we are just changing these different scenarios, when we are introducing some angles, or we are just changing the velocity, or even when we have different vehicles with different dimensions, etc. So this is what we want to address with this in this project, and this is why we are just changing the simulations, including these different angles, and see which ones are more critical, right? And you can see over here that the folding behavior of this frontal part is totally different than the other one, where there is this, where the cars are completely aligned. So this means that we need also to address these deviations that we may have in the reality, right? In our real cases. So then if we go to the next slide, we can see how we are addressing this point. It's clear that basically we're presented, we are developing this passive system. So having this HPDC part, the extruded profiles reinforced by using additive manufacturing. But then here also we're introducing this new concept that this is the active system, where we are using some actuators, and you can see in the right hand side, this is almost the last version of our component, of our HPDC component, where we're just putting here in the middle kind of a cylinder that we can adjust the inner pressure of a fluid, and then we can more or less play with the folding behavior of this component, or with the absorbed energy of this component. So this means that it can help us to avoid severe damage in these different situations where we are changing the angles, etc., and we can tune a little bit the crash behavior of our vehicles and improve the safety of these vehicles. So on the next slide is the last one. This is the main takeaways that I would like just that you have in mind when talking about or listening about this project. First, the main idea is to use this LMD technology, so print some reinforcement of our components, but using exactly the same material. So this means that we are improving the recyclability, so we are not having different materials in a single component that this is simply super complex to recycle. And then also it's our bet in order to maintain the conventional manufacturing processes like the HPDC or the extrusion, and then just have this extra performance or this extra behavior in terms of mechanical behavior by using the additive manufacturing, like using these LMD processes. And finally, just to have, we're working really hard on having a really good simulation models from materials and the interaction between the different vehicles, in order to, in the future, have this virtual homologation of the vehicle, right? Of course, we are working on producing different demonstrators that then we will just compare with the simulation, and this will just show how that we are capable of have this homologation of our vehicles in a faster way, and also in a better way. So, and this was my slide, my last slide. So thank you all for the attention. I will be happy to answer the questions. So thank you all.
Thank you very much, Sergi. Appreciate it. Very interesting and nice animations.
Thank you.
So we have 5 more minutes left. If anyone has any questions for maybe any of the speakers, feel free to drop it in the chat. And yeah, we can answer it, or we can ask the speakers. Anyone at all? Or would any of the 3 speakers like to say anything else after everything? Final words? Simon, go for it.
David, just again from my side, thank you very much for the opportunity. I know you've got a lot of information in very, very little time, so I'm not surprised that the audience are struggling to find the questions amongst the stunned silence that we're seeing. But no, thank you very much. And thanks to all the audience for listening as well. Thank you.
Thanks very much. Yeah, thank you to all the speakers. And on a final note, please register for the Forum. You won't regret it. It's a great event to meet all EARPA members and to get updated with all the latest news and updates from the automotive research sector. So yeah, scan the QR code and I'll send you all the slides and the presentations very shortly. So thank you all for attending and have a good day and see you soon.